Good afternoon, everyone. Thank you so much for joining us for this Transloading panel. Appreciate y'all coming out. I know the weather's not great, so appreciate you taking the time to come watch our panel. We're going to start off by making quick introductions to the panelists. We have a very esteemed group of panelists here to talk to you about streamlining transloading operations. And then after the introductions, we'll jump right into a few presentations, and then we'll kick it off. We're going to try to make this as informal and engaging as possible. First, let me start off with, to my left, Shauna Fairchild, who is the CCO of Commtrex. And then we have Matt Sewell, who is the CEO of Parallel Systems. And then we have Tim Lucchini, who's the CEO of Intramotive. So we're going to start off with giving a presentation of each of us on the different sort of solutions we provide. So I'll start off with Shauna.
Hello, everyone. All right, we thought you'd give you a quick overview of Commtrex in case you don't know who we are. So here's a map of our network, and really what we do is we provide intermodal, automotive, and depot services across the nation. We also wrap that in technology, which we're going to talk a little bit more about today. But we're really deeply integrated in supply chain. So when you talk to us, we would tell you that really the middle parts of it is what we don't do. So the line hauler over the road. We don't provide the railroad services over the tracks, and we don't provide the ocean over the water. But other than that, we pretty much touch every other part of the supply chain. So we have depots where you store your equipment, and we do maintenance and repair services. We also offer that intermodal services, both on the ends. So when you come into the United States at the ports area, and then also in the interior. And then we also are at shipper and receiver facilities, including transloads. And then here's just an overview of the different services we provide. So I've touched on a lot of those already, but we also wanted to make the point we wrap that all in technology. And so here really is the different technology that we provide. We're probably going to touch on a little bit of this today as we go through the presentation, but we have an automated gate system called SideIO, VeriSpot, our automated mobile inventory system, VeriStack that reads inventory in stacks, Dynamic Dispatch, which I have a video to show you in a moment, where we're partnered with Phantom Auto, and then LoadBright, which is an optimization product. And here is our video for Dynamic Dispatch.
In 2020, we announced our partnership with Phantom Auto, and after taking delivery of our first truck, we began our journey to operationalize the technology. We used our North American depot network as a sandbox environment to deploy remote operations and distance driver training. Teams in California and Texas collaborated to onboard drivers to start our program. We operate in port, rail, and warehouse environments that are highly complex. And we believe that remote operations are the most capable, reliable, and scalable when there's a human in the loop. We've identified operations where we can deploy our remote yard truck along with a bomb cart or terminal trailer to operate production environments in terminals today.
I manage a facility that shuttles shipping containers between short-term storage and incoming and outgoing trains. We use heavy-duty chassis called bomb carts or terminal trailers. The cornerless design removes the need to line up containers on twist locks. Instead, the container guides cradle the cargo, so each loading and unloading event is quicker, and we can load and haul two 20-foot containers. Combining remote operations with bomb carts just makes sense, and our employees couldn't agree more.
I've been working at the company for 21 years, so I was excited to hear that we're going to spin up remote operations. It's something I've never done before, and, well, it's the future. The onboarding experience was much like driving a Hostler manually. To get started, we inspected the truck, then we came inside and inspected the console. Then, as I drove the truck, there was a safety rider in the cab. We stayed in contact with the safety rider by two-way audio so I could course correct along the way. I spent time bobtailing, hooking up, and driving with a chassis, or in our case, a bomb cart. The next phase is traveling with an empty container, then a loaded one, and finally shuttling to the train.
The terminals where we operate are highly complex environments. So for that reason, we've intentionally adopted a remote-first approach for deploying and scaling this technology. Our drivers, like Sean and Andy, are positioned to remotely control all vehicle functions and execute the entire workflow within the yard. Our remote-first approach ensures that the solution can dependably and predictably react to changing conditions in the yard environment. We have the benefit of being experts in terminal operations and incorporating that expertise into the product development lifecycle in real time. We're collaborating with Phantom to roll out product enhancements based on our operator feedback. When our operators drive equipment manually, some areas around the truck have limited visibility. Here's where adding cameras around the truck really shines. We can direct the cameras to provide enhanced visibility for our operators, providing them with improved situational awareness. UI enhancements like customizing the layout of the camera feeds or displaying guidelines is also possible. These efforts will allow us to scale our operational footprint as we deploy additional trucks this year. And because we've approached our remote operations program in a modular, competency-based path, we can deploy additional trucks and drivers in a way that adds value in a shorter amount of time compared to fully autonomous technologies. Teleoperation means that remote operators can be located at the same site as the truck or thousands of miles away. This flexibility allows us to recruit and retain employees, including those who might not traditionally think of themselves as heavy equipment operators, allowing us to better serve our customer needs and remain resilient now and in the future.
I'm Matt Sewell, and I want to tell you a little bit about parallel systems because my experience, I find that when I try to describe what parallel is doing, it's very hard without a visual here. So I've just got a couple slides to try to support my explanation. So parallel is developing battery electric autonomous vehicles that use existing rail infrastructure, and this is a mission that we started because of climate goals. Rail is very fundamentally energy efficient compared to on-road trucks. The challenge, though, is the legacy architecture of rail is limited in terms of what types of freight lanes it can serve. So the reason we're developing this very unique platform is to address those limitations. We're not looking to replace rail in its current form. We're looking to add to it and give another set of tools to railroads to actually go serve lower volume lanes, shorter haul lanes, but also improve their ability to commit to service quality for the customers, which is just as important as the economics of it. And this bar chart here, if you can see it, just is analyzing the actual CO2 contribution from these various modes of freight movement. And so trucks are very popular today because of the flexibility they have, but it's very energy intensive. The rubber tires on asphalt, but also every truck individually experiences aerodynamic drag. Electric trucks are absolutely a positive step forward in terms of reaching decarbonization targets, but it's still very energy intensive. When you look at the operational CO2 to recharge that battery that has to come from our grid, you're still looking at a very high amount of CO2 per mile moved. And meanwhile, rail in its current form, burning diesel to do that same freight movement, you're burning so much less diesel that you're still less CO2 per mile than an electric truck. And so this is validation for why Parallel's mission here is not to replace rail, but to address these limits for why rail isn't serving more of this market. And we want to move more trucking activity to rail. And trucks are absolutely here to stay, have a very important role to play, but there's a huge opportunity for modal shift with a technology like this. A lot of what we're developing around this architecture is to be the necessary transformation to enable that. So we have to allow for truck competitive economics at smaller scale. That's why we have such a different type of vehicle here. And service quality is highly important too. A lot of the service quality challenges that rail has today is because of the costs and overhead associated with getting stuff on and off the rail network. So my next slide here is just a video just showing a highlight reel of how we're moving away from even conventional rail couplers, and we're able to dynamically make or break platoons. And we move in platoons because that's the right use of network capacity, but it's also more energy efficient that way. So what you're looking at here is just two vehicles on one of our test track, and we can move them together through software. There's no person required to actually be involved in the process. And so we make contact through a bumper, and what's very unique about this is that we share work mechanically by pushing from the rear, and this is what helps us amortize drag over multiple vehicles. So our effective coefficient of drag when in platoons of 10 or more is about 0.25, where Tesla Semi, which is state-of-the-art, has a coefficient of drag of about 0.35. And when we're moving on the network in this configuration, when the need arises, we can actually break that platoon apart and sort freight on the network keep a grade crossing open, but it gives us the ability to handle a lot of customer needs or operational needs without having to have a person directly there in the field. I think that's the end of my video.
Thanks, Matt. My name is Tim Lucchini. I'm the CEO of Intramotive, and I'll keep it a little shorter here with what we do. But what we do is we build battery electric self-propelled rail cars. And really that's with a couple of things in mind. And one of those is that rail does a lot of things right today, kind of the way that Matt was highlighting the efficiencies of rail, the operational efficiencies there. And I might just pause and check in with the audience and say how many people use rail or interfacing with rail on a daily basis and have some kind of touch points here. Yeah, so there's some, and maybe some education along the way as well, but ultimately rail does a lot of things right, and it does a lot of things right every day. However, there's still challenges, especially when you're a small customer, and even in the case of Intramotive, we're a small customer of the rail system. So when you're looking at how does one vehicle move on a rail system, the middle leg is very efficient. That efficient middle mile operation that a Class 1 handles today is probably as efficient as you can get it. However, when I got to get one car from Texas, it might take them 2 or 3 days to get it into a train that's 3 miles long. Then it might take 2 days to get to East St. Louis, where we're at. And we have a car right now that we're waiting on. We've been waiting on for a week. It's been in East St. Louis. And the railroads do their best to handle that with the tech stack that they have today. But I'm still waiting on that car right now. And that's a pattern that keeps happening to us. And we're here to fix that. So really, the way we think about this is, we'll see if this video pulls up for us. Yeah, there we go. So this is in our factory in St. Louis. We have a facility in North St. Louis. We have a test track in East St. Louis. But what we allow is a rail car to drive itself with that speed and flexibility of what you'd be used to seeing with a train. However, we retain the operations of a rail car. So we can run this car in 3 modes. It can run in a train. You keep the air brakes. You keep the couplers. You can run our system on or off. And in that system, when it's in that train, it turns the train into a hybrid. So now you have your diesel engine, which there's 38,000 engines in the US, but you can use our car to push that engine. And you can take the load off the engine. You can get rid of those extra distributed propulsion vehicles. And then when you go from the Port of Long Beach to Chicago, a long train makes sense. And then we can autonomously decouple the cars and allow them to go to Gary, Indiana, where a customer needs plastic injection molding pellets, or get up to Milwaukee, Wisconsin, where somebody needs to make beer, or get down to Peoria, where somebody needs a shipment of heavy metal or materials for making Caterpillar vehicles. And really what we do with these deployments and these customers is we're showing them anywhere from a 30 to 50% cost savings against traditional rail, because you get that asset utilization up. You can start to, instead of talking about 1,000 tons through a rail car a year, you can talk about 60,000 tons through a rail car a year. And then you also, against traditional trucking, are showing 50 to 80% cost savings, which is pretty drastic. And it's because of those efficiencies of rail, and the capacity is there, the network is there, and we're excited to be unlocking that. So I'll pause right there and we'll go into the panel from that.
Great. Thank you very much. Hopefully that was a great way to level set the conversation for transloading. Transloading breaks into pretty much 2 different categories. You have your bulk transloading, and then you have your container transloading. And we're fortunate enough to have 2 representatives today to speak to both. Let's start off with, before I start, if anybody will have any questions, please feel free to use the QR code that's on the screen to ask questions, and then we'll interject at the very end. Let's start off, if you don't mind, Tim, can you speak to the solutions you're currently providing for the bulk world, and which sort of specific niches within the bulk world do you see the most traction? And if you have an example of how it's being utilized today?
Yeah, absolutely. So happy to talk about that and where we're seeing these first deployments. We're really taking a pretty strategic approach to how we bring these technologies to the markets. And where we're starting was with things like bulk materials. So we're deploying to a calcium mine in northern Michigan. We're deploying to a mine in southwest Pennsylvania. They have very consistent tonnage movements. They know how many tons of material they need to move per year. They know what their current cost is. We know what we can compare that to. And we operate in their environments, giving them operational flexibility. So today, if they run a big train and they might have maintenance associated with that train every year, today, if that engine is down or their crew doesn't show up, they can't run. When we add a bunch of these tug volts and revolts to their system, if they lose 1 tug volt, it turns into a rail car. They can keep running at 80% capacity or whatever their system is designed around. And that's pretty consistent as well. And then I think one of the other really interesting things is you can run this remotely or autonomously. So when you start running autonomously, you might do main route sections that might be 18 miles autonomously. Then you hand that off to a person locally who can remote control it. So you don't have to send that person with the vehicle to that end state, but you can still operate it line of sight if you need to, or you can do it from a central dispatch facility. It's a pretty big value proposition for a lot of these facilities. And we're also helping them with zero decarbonization premium because they're saving money on this, helping them electrify. And so it's pretty exciting on that side of things to actually have a very solid business case first, and then you get all the other things on top of it. So one customer is looking at 60% cost savings, smaller total fleet size, and eliminating 12,000 tons of CO2. That's a really good use case. And it's pretty consistent across these first phase of the markets. And then we kind of grow from there. So you go from a mine site to then maybe an interchange connected route, and eventually Port Long Beach to Chicago, where that 3-mile train isn't actually consumed in Chicago.
Why did you decide to focus on bulk?
Honestly, it's one of the places where the pain point is very visible and people don't pay that close attention to it. So I came from an industry where I understood how containers might move and how containers go from one place to another. I knew nothing about manganese. I knew nothing about calcium movements. I knew nothing about sand or any of these other materials that need to move. I never thought about a steel mill and how they operate. And then once we started going to these customers and seeing what they're actually doing and them telling us on these short legs, they're paying $5 a ton to move material 3 miles. That's really, really obscene. And we showed them we could cut their cost by 80%, give them flexibility, and ultimately they'll service their customer with a better product because of that. So we see a ton of opportunity there, and it just makes a ton of sense.
Great, thank you very much. Now moving from bulk to containers, Matt, could you talk to us about the solution you provide and maybe give us an example of how customers are using your solution?
We're still in early pilots right now, but how we look at customers using the solution is really opening new intermodal freight lanes that realistically can't happen today because of the economics that we're addressing. So the limits are usually service quality. Customers will expect minimally one arrival departure time per day. They want predictable service. And when you get to low density lanes, because of the scale at which rail prefers to operate for financial reasons, it's very hard to accumulate freight and meet those service quality needs when you're talking about a low density lane. A lot of the network exists already. It's just that you don't have the services stood up there. The other angle that we're enabling is that you have to reduce drayage costs. Drayage costs become a limiting factor for the length of lane that you can realistically put intermodal freight on for rail. When the drayage costs become too high, it doesn't make economic sense to put it on rail. And so a lot of what's unique about our platform is to enable higher asset turn, which means combined with the lower volumes that we were able to sustain, we can have smaller terminals, and smaller terminals can be more strategically placed closer to shippers and customers and keep those drayage costs down. In extreme cases, we actually make the customer's facility part of that terminal. There are a lot of import facilities around ports who have regular steady volumes of containers, 50, 100, maybe even 1,000 a week. And it's a significant volume of containers, but rail in its current form cannot serve that type of customer. With our platform, you can have a few containers at a time, arrive multiple times a day, and you're still feeding those containers much like you would with a truck drayage service. So these are some examples of how this platform enables rail to be used in new ways that wasn't really feasible before.
Of all the different advantages that there are to your solution, is there one or two that particularly stand out when talking to customers that they really jump on as far as the benefits to using your system?
I mean, service quality and economics drive a lot of this industry. That's the clinical nature of it. No one's paying for a train ride or a truck trip. They want to know how fast and how predictable and what it's going to cost me. But there's a lot of growing interest in the carbon footprint of freight movement too. It's not every shipper today, but we're seeing growing interest in, I want all those things, and I want to be able to claim that we're actually making progress towards our own decarbonization targets. And that's what has guided Parallel's mission. There's a few layers to our story. We're absolutely paying attention to what the industry wants, which is the economics and service quality, but the industry also wants cleaner solutions too. And that's where we're seeing a lot of engagement around the possibilities there.
Thank you, Matt. Shauna, I think a lot of people in this room are familiar with Global, sort of overall for the intermodal operations, but can you speak to the technology aspect of what you do in Global, in particular, any particular solutions that you are sort of most proud of?
Yeah, absolutely. So I showed one slide that showed our Avira 360 platform. So we have 5 different technology products that sit on that platform, and they can be used in conjunction with one another or used a la carte. I'll talk first of all about VeriSpot, which is our mobile inventory solution. And the reason why I'm going to talk about that is because it's applicable even in the transloading space. First, I'm going to talk about it quickly in an intermodal rail operation, and then I'll talk about a transloading opportunity. But we have implemented VeriSpot in many of our railroad intermodal operations, and it has allowed us to become more efficient. So an example of that is now the operations folks do not have to go around and look to find containers. That sounds really simple, but surprisingly, inventory isn't as accurate as you think it is at a terminal. So, prior to us implementing our technology, it could take somebody 6-8 hours to do inventory on a terminal. And so basically, just a few minutes later, after you walk past a container, that is already dated information. So when people were going to load trains, it could be frequently that they could not find a container. So now that we've implemented VeriSpot, they always know in real time where the containers are. So this has allowed our team to get trains out 59 minutes faster at the terminals that we've implemented this technology. So that's a really big deal, especially at terminals where we're doing business for certain parcel customers, if you know who I'm talking about. But now take that into transloading facilities. So we have also coupled that with our gate technology at transloading facilities. And so we have a particular transload customer that is using our gate technology, Side.io, and they're pre-registering their drivers. And that allows the drivers to show up, and as long as our AI verifies all the right information, so let's say I've got CMAU 123456, I'm expecting that a certain DOT number, license plate number, whatever it is that they need, then they automatically get let into the facility. And then VeriSpot lets you know, for example, that dock door 4 is ready. And so previously, the YMS would say, it's going to take 2 hours to unload a container, so dock door 4 may not be open for 2 hours. Now, if it really only takes half an hour to unload that container, VeriSpot knows a half an hour later that dock door 4 is open. So that's increased the efficiency at that terminal, because now, a half an hour later, it can tell someone to take something else to dock door 4. We're also working with the YMS to let essentially people know where to go and take hot loads. And so that's been another thing we've been able to do for this particular customer. So we're basically all of the important underlying data that goes into the YMS that powers everything with, outside the 4 walls that can also help inside the 4 walls.
Great, thank you, Shauna. Now, I think all of us here have heard about the tailwinds that rail has with sustainability. Great buzzword, but is it really something that shippers care about? Is it really something that you think within the next sort of 2, 3, 4, 5 years will drive decision making with the wallet, not just sort of speaking at it through a press release? Shauna?
So what I would say is, yes, that customers do care about sustainability. And they're adopting it at different levels of speed. And so, for example, we have some customers that we have rolled out EV hostlers with. We have one rail facility, for example, that is fully electric hostlers. And we are rolling out a second facility with that same customer that we're going fully electric there as well. So we have, for example, 50 electric hostlers today, and we're quickly bringing on 38 more. And then as we are implementing the dynamic dispatch program that we showed the video for, we're also going to have an EV component to that as well. So some of our customer base has asked for an EV solution to go along with that product as well.
Matt, can you answer this question?
Sustainability is absolutely a tailwind, but I think to add to what Shauna was saying, there's 2 things that I see as additional tailwinds that are not sustainability for railroads. Number one is, I think there's a lot of consensus building that railroads' operating ratios are asymptoting. And so to actually grow profitability, top-line revenue has to grow. And I see trucking is where a lot of people have put their eyeballs in terms of looking for that growth, is converting trucking to rail. The other thing that I think is a big theme for rail in terms of this transformation is thinking about how do we increase the utilization of our assets. This is basic business principles, but there's an opportunity to think about intermodal terminals, like how do we increase the utilization of that real estate, but also the assets that exist on top of it. And so a lot of the work that ConGlobal is doing is directly addressing that problem, but there's things that Parallel is doing as well to really help with faster asset turn. Like we think a lot about drayage, not just like we're doing a technology deployment for rail. We think about how does this complement the future of trucking? How do we enable terminals that can be smaller, so lower capital thresholds to even just get out there and start opening a lane, but to get that driver in and out of there faster as part of the driver experience, but then they're driving shorter distances. So instead of doing 3 turns a shift, maybe they're doing 6 turns a shift, which is going to cut your drayage costs in half. So those are some of the themes that I see as like being a tailwind for this industry.
Well, and even to that point on turn times, I mean, the ability to be able to get people in and out of terminals like you're talking about, that's something else that we're doing with our gate technology, right? So we talked about that pre-registration process. So if you're able to pre-register and not have to stop at that gate, you're reducing idle times. And other technologies are able to do that with, for example, is the Samsara product, which isn't ours, but we utilize that to reduce idle times on hostler trucks. So we found that if you're idling in your own operation, you could figure out how often you were doing that, utilize that technology, and then change behavior, essentially, so you were not idling the whole time you were using those trucks in your operation. So again, there's all kinds of ways that you can do that.
Hey, Tim, did you want to speak the same thing?
Yeah, so from the environmental piece, I can't talk to like the whole industry and what people are going to do, but I can say I personally care about this. I think I have an interest in it, and I think that's true of a lot of people. Like, we want this to be true and find a solution where we can electrify and decarbonize and everything else. And I tend to think in anecdotes, and I went fishing last weekend in northern Michigan, which I've done every year for since I was a kid with a bunch of friends. And this year, instead of ice fishing, we went to the bar because there's no ice up there, which is a weird thing to be thinking about. And then what piece can I do, or what can Intermotive do to help solve that? And really, it is decarbonization of transportation through battery electric rail cars, where the scale of the rail car and the scale of the battery tech and where these two things intersect at is actually right-sized. I don't have to wait for a material science breakthrough in battery tech to get 40 to 50 times more energy density into a battery, which is what you have to do when you're competing with diesel. And I don't have to wait for things to progress a certain distance to make electric trucking feasible. This is the solution that makes sense. We can move something 3.5 times the weight of a semi, going as far as 100 miles with as small battery packs as what you'd see from a Tesla electric car. And that type of scaling thing is pretty magical. When you can then just add more cars, you start getting more range, you start getting more payload, and you do it scalably. Where today, if you want to have an electric car, range anxiety is a real thing. So people buy 300-mile range cars, even though most of the time they only go 50. And the approach of electrifying that whole train through Intermotive type of technologies, you just add more cars, you get more range. You don't have to buy that 300-mile battery pack on day one. And that's part of the solution set that when we show this to customers, it is an immediate cost savings to the bottom line and the benefits of electrification. And that is one thing where you can't have one without the other.
Great, thank you, Tim. We have a few more minutes here before we wrap up, but wanted to do a few rapid fire questions. Let's start with Tim. Tim, if you could use one word to describe the future of transloading with respect to technology, what would that word be and why?
Yeah, I've been thinking about this since you posed that to me and gave me a free form chance at an answer. And really, I think it's flexibility. Like, if I look at the future of logistics and transportation, whatever mode you pick, whether it's a boat, a ship, a truck, or a rail solution, I think it's going to be more flexible. And I think the way that you get that flexibility is in a smaller modular unit that is scalable. And it's on the scalable of the order of 1, 2, 3, up to what they think of in Class 1 rail today of 300 cars, a train that might be 3 miles long. And the way you do that is you take an Intermotive tugboat, and then you allow that car to be backwards compatible, and you also allow that car to pull 5 fully loaded regular cars with it, which we can do. And what that does is it gives you that flexibility of, do I want 1? Do I want 2? Do I want 5? Or do I want 300? It doesn't matter anymore. And I think that's kind of the future that I see with the technologies that we're building and the approach we're taking to this industry.
That's a great term to use for transloading. Really, that's what transloading is. The essence of it is really providing that modal flexibility. And I think that's what all of us up here are trying to achieve, is creating more modal flexibility for our shippers. Matt, question for you. In a world where your vision for parallel systems is able to be achieved, what feature of your technology do you believe is going to have the biggest impact on this industry?
I don't want to steal from Tim here, but I think flexibility is a key feature here. We want more freight by rail, and it has to be more flexible to do that.
So with respect to flexibility, What specifically do you think, why is it important for shippers to have that flexibility?
Because of their needs around service quality. They need to have predictable service quality, which requires adaptation. When you're trying to shoehorn everything into a big, long, 3-mile-long freight train, that's the opposite of flexible.
And do you see the railroads being very supportive of the notion of more flexibility for shippers?
The railroads, I think, are aware that there's an opportunity for growth here, that they're trying to figure out how do they take advantage of that need.
Great, thank you. And Shauna, as far as intermodal operations, what do you think is going to be the most important feature technology-wise, whether it's something that ConGlobal currently does or whether it's something in the future that you really think is going to be a defining feature for what really sort of sets intermodal apart from other sort of modes of transportation?
So the workforce is changing. That's one of the things, is that it was already changing. And then with the pandemic, that's been the thing that we've seen probably the most. And so with that, you have to think about work differently and how we do the work differently. Now, there's all kinds of ways to do that, whether it's through how we schedule and how we do shifts or how we treat the people that work for us. But, it takes us back to the video I showed at the beginning with dynamic dispatch. So I don't know how many of you have worked in operations, but, I live in Omaha. Many of our operators work in places like Chicago, Kansas City, St. Louis. And I don't know if you know that it was like negative 45 degrees about 2 weeks ago. And those folks work outside in that negative 45 degree weather in the middle of winter. That is hard, challenging work, and it's getting harder and harder to find folks to do that. And so with our dynamic dispatch program, we are able to hire workers to work in the comfort of an office building, driving what looks like a PlayStation steering wheel. And they get to operate that remote operated truck from the inside of that building. And so what I can tell you is it makes it a lot easier to want to attract and retain talent. I've got a whole gaggle of teenagers at home, and they were all like, how soon can I drive that? But in addition to that, it also gives more flexibility even in the whole supply chain as a whole, because our partners at Phantom Auto also do remote operated forklifts. And so you could have somebody, if you had a facility that did both, yard spotting and needed to do that as well as operate in forklifts on the inside, you could have somebody that, if you only had work during part of the time to do the outside hostler truck and then had to turn around and do work inside with the remote operated forklift, you could do that. And so you had, essentially more efficiency there if you didn't have, 8 hours of work doing one of those particular pieces of work. So again, this allows you to do your work in a different type of way, allows you to attract and retain talent. And not just, the people that are doing the work today, but folks that are disabled, people smaller stature. I mean, again, it really opens up your ability to grow your workforce. So.
Great. We have a few more minutes left here. We have a question from the audience. This is specifically with respect to Class 1 railroads. And what can Class 1 railroads do to help support the growth of transloading?
I think the person that came from a Class 1 maybe should take a stab first for us.
Really it comes down, in my mind, to not being in silos, right? So from a supporting transloading, it's all about everybody working together. Some of the ways that the Class 1s can do that, as probably many of you know, some of the Class 1s have transloading facilities right on site. The other thing is to support the adjacencies. So transloadings are frequently more and more being stood up right next to intermodal facilities in logistics parks. So that's something that's happening more and more. But that's really what I would say is if you could work together with those transloaders, make sure that the communications are there. You're integrating with them with API, not EDI, API. That would be the best way that I can say that you could support them.
Great. And to piggyback on that, lastly, what can short line railroads, Class 2s and Class 3s, and independent transload operators, how can they help support the growth of transloading?
Yeah, that's really interesting. And I think my answer is kind of tie those two things together, which when we're looking at what the solution is that we've built at Intramotive and we think about how these rail cars move, what we've built really helps the Class 2 and 3 railroads most. People that do have those customer touch points, that do have to figure out how do they keep a customer that is currently serviced by rail, that maybe has a plastic injection molding plant making bumpers, serviced and keep their production line running. And then how do we help Class 1s in that is we help them get cars back to those main hubs quickly, aggregate them into longer flexible trains if that's the way they want to run the operations, and then get back down to a single unit again when you have to go back and get that loaded or get it unloaded, wherever that goes. And I think really that's the tool that we've built and there's a number of ways you can use it, but that's probably one of the first visions I have for how you drive value out of that.
Matt, did you want to add anything before we close?
Just to add to the short line here, since we're at time, I think another motivator for short lines in terms of this transformation change is that they usually have a very low diversity in their customer base. And so it's very important for them to have a set of tools that allows them to go out and support a wider range of customers so they have more diversity on their railroads.
Great. Thank you very much for all of you joining us. Hopefully this was helpful and provided some insight on the future of transloading and how the future is going to change with railroading and transloading in particular. Thank you very much. Have a wonderful show.